Okay, today our lesson is on vectors. Vectors relate quite nicely with what we just talked about. A vector such as if I draw kind of a geometrical representation, that's what we used to draw for a ray for geometry. A vector is slightly different in that it doesn't go on forever. It has an end point to it. So it starts at the initial point of A and goes to the terminal point of B. So the initial point A and the terminal point B. Okay. Vectors have some interesting characteristics. Number one, vectors have length or magnitude. So magnitude is simply the length of the vector. And you can add vectors. You can have sums of vectors. You can have difference. You can have scalars that multiply and everything else. But what makes vectors special, they have magnitude and they have direction. Nobody's laughed yet. Hopefully we have one. Okay. All right. So you're thinking of, yeah, let's watch it, huh? You ready? That's the point where I started laughing in the theater and nobody else was laughing. Love the math jokes. Put on again, one of the best inventions ever. I want one of those. I would totally shoot it at you guys. You give it. It'd be funny. Yeah. So there you go. Vector, super fun. Gotta watch it every time we bring that up. So yeah. So let's do a geometrical representation of vectors. If this is vector B, anybody guess what negative B looks like? Opposite direction, starting at the same location, but opposite direction. You may want to guess what 2B would look like. It would double in length. 1/2 B, shorten it, okay. And then negative 4B, 4 times in the opposite direction. So we did our best to approximate. Maybe we got a little carried away with that last one, but it was exciting. Kind of hold myself back. Good. Now we have two vectors that start at the same point right here, and we are going to show the graphical representation of some of their addition and subtraction as well. I'm first going to show negative A, and if that's A, then that would be negative A. If this is B, then I have negative B. So what I want to now show is A plus B. So if you think about this vector, and we're going to add that vector to it, what would it look like? And the way to compute this is to draw a line on B, and then what I'm going to do is I'm going to move that onto the end. What happened there? Oh, sorry about that. Somebody who remained unnamed was throwing my markers around last hour. So again. So anyway, so that would be A plus B. So the result is this vector, A plus B. Yep, you connect it from the beginning. Vector A plus B. Yes. This is just how we find the endpoint. This is the actual vector. Yep. 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 And if you want to do A minus B, we're going to take vector A and attach what onto it? Negative B. And you can see you get this vector, which is A minus B. If you want to do vector B minus A, you take B and attach onto it negative A. And you have this resulting vector, which is B minus A. Okay, so vectors are written in component form, and component form of a vector is like this. So instead of parentheses, we use kind of a sideways V, so to speak. And in order to determine A, you take the second x value minus the first x value. And to get the B value, do y sub 2 minus y sub 1. So, yeah, kind of. So you have a vector that connects point P to point Q. It goes from 3, 4 to 7, 5. So here's all it is. How far does it travel horizontally to go from 3, 4 to 7, 5? 4 units. You did 7 minus 3 is 4. And then, how many units does it travel vertically? 1. 1 unit up, so it would be 1. So you just subtract the x values, subtract the y values. Again, Q is always the second point, so this is x1, this is y1, this is x2, this is y2. So go ahead and determine the component form of the vector for the next one on your own. Go. Should be 7, negative 3. Any questions there? Good. Really not that tough. Magnitude of a vector. Vectors have magnitude and direction. We're now going to give you formulas for magnitude and direction of a vector. So you don't have to write this down, but on a scratch sheet of paper, I will show you that if we have a coordinate plane, and in that plane we have a vector that is vector AB, what that means is it travels A units horizontally, and it travels B units vertically. And so the magnitude of the vector would be the length of that hypotenuse of that triangle. How would you determine that? Pythagorean theorem. So this should look familiar to you, because we've seen this before in other situations. The magnitude of a vector is equal to the square root of a squared plus b squared. So vectors are very closely related to our study of complex analysis. Notice that that's the same as r, or the same as the modulus, the absolute value of z. And when you talk about the direction of a vector, we say, well, we want to consider theta. And what formula do you have for theta? Tangent of theta is b over a. Yep. So we have those two nice pieces right there. That looks pretty straightforward, doesn't it? Okay. Ava's dancing. Very good. We're going to get rid of this sum of vectors pieces there. We don't need to talk about that. We'll use this space. We're going to find the magnitude of each vector and the direction. So the magnitude is the length of the absolute value, and in order to do that, I do the square root of 25 plus 4. So the root of 29 is the magnitude. Yeah. Nope. And then to find the direction, we say the tangent of theta is equal to the b value divided by the a value. So in which quadrants is tangent negative? Second and fourth. Is this in the second quadrant or fourth quadrant? It is in the fourth quadrant. So I know I'm somewhere in the fourth quadrant. I draw my reference angle. I go to my calculator and I type in tangent inverse. Just came from calculus, so I was saying in radians. For vectors, you get to go back to working in degrees. So it's only for your complex analysis stuff, chapter 7.6 that you were working in radians. So for the vectors, you go back to degrees, and we do tangent inverse of 2 divided by 5, and we come up with 21.8. So that's in the fourth quadrant, so we know that theta is equal to 338.2 degrees. From 360. Nope, you leave your vectors in degree form. Okay. All right, the next one, 0, 3. I'm not going to use my formulas here. I'm just going to draw a graph. 0, 3 would be plotted where? Yep, 3 units up on the x-axis. So the magnitude of the vector is the distance from the center, which would be 3 units. And then the angle, we can see if it's plotted on the y-axis, the angle is going to be 90 degrees. So if you can recognize that it's an easy angle to find, then go ahead and just do that. Don't worry about your whole tangent inverse. The next one, I have the square root of what? 9 plus 16. 9 plus 16 is 25. Square root is 5. So the magnitude of the vector is 5. If you notice, a nice 3, 4, 5 triangle. And then we set up tangent of theta is equal to 4 over 3. Which quadrant is 3, 4? That will be the first quadrant. So we can simply just inverse this, and we know we come up with whatever value the reference angle is. 53.13 degrees. Yes. Yes. So what mistake is made on the test? Right here, people put their angle as 21.8. Now, have they done some good work to come up with 21.8? Yeah. But is it going to be 21.8 degrees? No, drives me nuts when I see that people put 21.8, but it tells you right there it's in the fourth quadrant. You know it's got to be between 270 and 360, but people still just write the 21.8. I don't know how many times I tell people afterwards, like, oh, I never really got that. Yes, you did. There's not a single person here doesn't know that that's fourth quadrant, okay? Not a single person, so don't do that on a test. Drive me nuts. All right, so let's do some arithmetic with these vectors. Given vector A is 1, 3, and vector B is 2, negative 2, determine 3A. So what do you think we do to determine 3A? Yeah, you just distribute the 3, and when you do that, you get 3, 9. If I compute 4B, you distribute 4, and you get 8, negative 8. The next one's a little different because you're doing multiple operations here. You're adding and you're multiplying by 2. So I'll organize my work a little bit. All right, vector A is 1, 3. And then 2B is vector 4, negative 4. And as we add those together, we get vector 5, negative 1. Why don't you try the next one on your own? Go. As I subtract those, 2 minus 10 is negative 8, and 6 minus negative 10 is positive 16. I've got negative 8, positive 16. Good? Told you it wasn't tough. Just new, right? One thing you're not going to use very often is that sometimes vectors, instead of being written in this component form, they can be written in terms of ij. And the book does this. I don't know if this ever comes up in a different scenario, but 3, 9 can be represented as 3i plus 9j. You're like, why would they do that? So the only reason I could think of is maybe like back when they had typewriters, maybe they didn't have a type key for that symbol. You know what I mean? Like how they represent a vector, they just use ij. I don't know. I'm guessing. Somebody on YouTube is watching the video right now. We're laughing. That's not an idiot. They used to do because of this. Yeah, who knows? So what would 8 negative 8 be? That would be 8i minus 8j. That's it. Okay? So if you ever see it expressed like that, that's all it means. Okay? So the last big piece for the day is the horizontal and vertical components of the vector. So I'm going to go back to my little drawing here. Okay? And what I want to do is I would like to write a value for A. A is the horizontal component of the vector. B is the vertical component of the vector. So if I look at the magnitude of B, theta, and A, which trig function comes into mind that uses those? Cosine. Namely that the cosine of theta is equal to A divided by the magnitude of B. And so if you solve for A, you get the magnitude of B times cosine is equal to A. Then you have this, sine. So sine of theta is going to be B divided by the magnitude of B. Magnitude of B times the sine of theta is equal to B. So, as we go to work here, that's what we want to do for our horizontal and vertical components. We have AB is the same thing as A is the magnitude of B times the cosine, because cosine is horizontal, and then B is magnitude of B times the sine of theta, because that is vertical. So I always think of cosine as horizontal and sine as vertical. That's what I always think about for all trig operations. So I mentioned that when I was in high school, I never learned SOHCAHTOA. I didn't. I just always learned that cosine was horizontal and sine was vertical. So, and for those watching the video, yes, that means I rotated the triangle every time. Express the following vectors in component form. So this is kind of the last skill we want to do today. We have one more problem on the back side. It's going to be a review of something else. But what this means is you have a vector of length 3 that goes at 30 degrees. So we're wondering what are the components if that's my vector. And that's not tough for us to figure out. We just say A is equal to the magnitude of the vector, which is 3 times cosine of 30 degrees. And then B is equal to 3 times the sine of 30 degrees. Now, if you're able to determine an exact value, then I want you to do that. So, for a 30-degree angle, what is the terminal point right there? root of 3 over 2, 1/2. So cosine is the x value, so we have 3 times the root of 3 over 2. And sine of 30 would be 1/2. So you have 3 times 1/2. So your component form would be 3 roots of 3 over 2, comma, 3 over 2. The direction states write it in terms of I and j. I don't really care, but just for good measure, I'll write 3 roots of 3 over 2i plus 3 over 2j. I was just going to say, it's getting hot here. And the air conditioning just turned on. I have magical powers. I have not told you. I'm a wizard. Not quite like Gandalf, but kind of like Gandalf. I love Gandalf. He's the best. He's the best. Try next one on your own. Go. Go. I think Gandalf is one of the greatest movie characters in the history of cinema. Aaron, do you not concur? Do you know who Gandalf is? Have you read the books? Did you read The Hobbit? You did not read The Hobbit? Are you a reader? Okay. Read Harry Potter? Okay. So my children, grew up reading Harry Potter, Percy Jackson, those books. My daughter's a year older than you. My son's, 3 years younger than you. But one of their favorite books ever is The Hobbit. It is, and even at age, 16, 17 right now, The Hobbit is truly if you like to read, if you're looking for a book, it's just a beautiful book. The other 3, the Lord of the Rings trilogy, it's not quite as enticing. So, no, come up with the exact values. You asked why, I will tell you why. Okay, so we will help you, Ms. Caitlin. Caitlin is looking at 315 degrees, and she recognizes that it is going to be a 45-degree reference angle, right? Because 360 to 315, that's 45 degrees. In the unit circle, the radius is always 1. And to go to the other side, we divide by the root of 2. So 1 over the root of 2. Which when you multiply top and bottom by the root of 2, you get root of 2 over 2. And this is negative root of 2 over 2. So those are our terminal points. So you should have A is equal to 4 times the cosine of 315. And B is equal to 4 sine of 315. Per what we just wrote, you can see that the cosine of 315 is the root of 2 over 2. And per what you wrote here, you can see it is 4 times negative root of 2 over 2. And so we get 2 roots of 2, and we get negative 2 roots of 2. So the component form is 2 roots of 2, negative 2 roots of 2. Not too bad? Okay, last example. Flip it over. Determine the magnitude and the direction of the vector. So the magnitude of V is equal to the square root of what? 1 plus 4. So we got the square root of 5. Thou shalt not get that wrong on the test. Come up with the angle. Tangent of theta is equal to what? Negative 2. Good. Which quadrant am I working in? Second quadrant. A tangent inverse 2, and I get 63/43. That is not your final answer. You're going to subtract it from 180, so theta is equal to 116.57 degrees.
Again, people write the answer to 63. 63 is not the answer. You are working in the second quadrant as plain C.
Okay?
So what if we give you some more complicated numbers? I have the magnitude of the vector is equal to the square root of, what happens if you square the root of 3 over 3? 3 over 9. And 3 over 9 is 1/3. Now add to that 1 or 3/3. 1/3 plus 3/3. So I have the root of 4/3. So I have the square root of 4 is 2, and the square root of the bottom is the root of 3. Multiply the top and bottom by the root of 3, and I get 2 roots of 3 over 3.
Good?
Suppose we set up tangent of theta is equal to b divided by a. The b value is -1. The a value is the root of 3 over 3. Is this my final answer? No, so you don't have to worry about trying to simplify that ahead of time. You can just go ahead and inverse that tangent right away. Tangent inverse of 1 divided by, parentheses, make sure you put parentheses around everything in the bottom, root of 3 divided by 3. And when you do that, you come up with, whoop, I noticed I made a mistake in my parentheses, didn't I? Sorry about that. I should have a parenthesis right there to close the square root. Then I divide that by 3. My mistake. I press enter and I get 60. Which quadrant are we in? Positive negative is going to be the fourth quadrant. 60 degrees in the fourth quadrant. Theta is equal to 300 degrees. Good work. Please take out your assignment. Notice problems 1 through 6 ask you to graph those vectors. Now, you can first compute them by, say, the first one you multiply by 2, the second one you distribute -1, and then go ahead and graph them, right? Number 7 and 8, it says find, those values. That's not going to be a problem for you. But look at number 9. It says find the absolute value. That's a symbol for magnitude. So finding the magnitude of u and the magnitude of v, that's not tough, is it? Look at the next one, the magnitude of 2u. So before you find the magnitude, what should you do first? Multiply it by 2. Then you can go from there. On the back side, you're simply doing what we were doing before with finding the vertical and horizontal components, and then you're finding the direction and the magnitude. And these problems do not take very long. Your last 2 assignments, the problems took a long time. These do not. So enjoy them. Be able to work through them quickly. And we will plan on testing next week, Thursday. I will plan on having your study guide ready to go by Thursday this week. Okay? I said Thursday, you look sad all of a sudden. Did I interrupt your plans? Your plans for Thursday? Okay. It's okay for me to schedule Thursday? I'm scheduling Thursday.